Welcome to our channel. Today we are going to see four important application of image processing using MATLAB code. So the first code is nothing but the explanation of MATLAB code for image segmentation using k-means clustering. Second program we are going to discuss about face detection and tracking using KLT algorithm. Third one we are going to do edge detection using fuzzy logic in image processing toolbox. The last one, active contour segmentation. So first we will begin with image segmentation using k-means clustering. So image segmentation is nothing but segmentation of various parts of an image. So here you can see the code. So before running the code, I will just show you the output so that you can visualize how the output will looks like. So this code will generate around 5 to 6 images. So first image is nothing but the input image, and second one labeled image, third one is nothing but montage of Gabor filter. The fourth is also the montage of Gabor filter. The last one labeled image with additional pixel information. So now I will show you those output images and all. So figure number 1, here you can see this is the input image, and figure number 2 is nothing but the overlaid image, and figure 3, here you can see it is a montage of Gabor filtered image, and the next one is also the Gabor filtered montage image. The last one is the final output of our code. So the you can see the dog image is perfectly segmented. So now I will go for the explanation of the code. So first is I am read of kobe.png. So resizing that image, reducing. Why we do reducing? Because the size is more, the running time will be more. Then we have to do k-means segmentation using k-means clustering. For that, the command is imseg k-means. Then we are doing the overlaying of the colors. So it is called as labeled image. After that, we are doing the filtering operations. The size is 24 Gabor filters. It covers 6 wavelengths and 4 orientation. So wavelength and orientation, we have to mention the values. You can change any numbers. Any code in MATLAB codings, you can give the numbers of your own choice. So then we are applying the Gabor filter. So after applying the Gabor filter, we are displaying the image in the form of montage so that many images will appear in the single frame. So after applying the Gabor filter, we have to apply the imseg k-means so that the misty area will be perfectly segmented. So here you can see the second image. Here you can see that the yellow color is overlaid on the dog's head, which is an unwanted thing. So to remove that one, to segment the dog image alone perfectly, we have applied the Gabor filter. So that's all about this segmentation using k-means clustering. The next code we are going to see is face detection and tracking using KLT algorithm. So face detection and tracking using KLT algorithm. So first work is we have to detect the face. Then we have to do tracking using KLT algorithm. So for detection of face, we have to use this cascade detector object, which is nothing but the implementation of Viola Jones algorithm. So this is nothing but the implementation of Viola-Jones algorithm. Then we have reading the image, reading the video named titled underscore face.avi. We are extracting the face. So this face alone is detected. We are using the boundary box rectangle. So that particular object has been found. Then we have to extract the eigenvectors. So detect minimum eigen features. So what are the features present in our face? We need to detect. Why we are detecting? Then only we can able to track the face perfectly. So here you can see the points dot location and all. Vision dot point tracker based on the max bidirectional error. Then we are running the video. So to run the video, we have to keep that video online. So that's why we are using while loop. So for each and every frame, we have to detect the points, which is nothing but the facial features. So the features are displayed in plus symbol. So I will run this code. Okay, here you can see the video, the face is tracked. Okay, so now I will show you the first image of this figure one. So this is the input image. His face alone is detected with rectangular bounding box. Next, we have to extract the features. So features is extracted based upon the minimum eigenvectors. The last one is the video tracking, in which wherever he goes, his face is detected, his face is tracked continuously. So now I will show you the his face tracking video so that you can see the tracking. So this face tracking, since I'm using the Zoom app, it is difficult to show at the beginning itself. It's not displaying in Zoom, but this is the final output of after the tracking is, so this is the facial features. So the last output is the person is continuously tracked, the face is continuously tracked. So this is the code, second code, which is nothing but face detection and the tracking using KLT algorithm. The third one, we are going to detect the edges using fuzzy logic. So earlier we would have discussed about edge detection like Sobel, canny edge and all. Now we are going to display the fuzzy logic. So initially what are things we are doing here means we are finding the gradient values of the input image named peppers.png. We have to convert that color image into RGB, from RGB to gray image. Next, these codes are nothing but we are finding the gradient. So gradient will tell the where are the objects located on the image. So then we have to create the fuzzy logic. So fuzzy logic, you can see the command window. I am typing the word command fuzzy. So this fuzzy logic is displayed here. So can you able to see the fuzzy logic screen now? So this is the input. In input, you can see MF is nothing but membership function. So in input, you can see MF is the membership function. Similarly, the output also will have the membership function. So input, and this is called as fuzzy interference systems. So when you do double click of that fuzzy interference system, you can see a place named rule editor where you can frame the rules. If input is M of 1, then output is M of 3. Add rule. If M of 2, M of 3 is input and M of 2 is the output, add rule. So similarly, you have to frame all the rule lists. Then you have to detect the edges. So here you can see they have created the MAM fuzzy interference system named MAMDANI. Add the input, add output, add the membership function values for both input and output. Then plot it. Rules list are formed. Two rule list is created. Based upon the two rule list, we are doing the we are detecting the edges. So we are not directly applying that concept to the image. First, we are creating a equivalent matrix of the same size. That's why size of I zeros. And wherever the objects are present, since we have the gradient values already, so in those areas and all, these edges will appear. So I'm running this code. So whenever you run the code, you can see the rule lists are displayed at the command window. So all the rule lists will be displayed in the command window. Nearly 6 images are created here. So let me show you the first image, which is nothing but the input image. So peppers.png. And next thing is figure number 2, which is nothing but the gradient value ix. And figure number 3 will be gradient value iy. And next figure 4 will be the properties of that degrees of membership. So the rule list black, where is black and where is white. And the last one you can see is edge detection using fuzzy logic. So I will also show you how the what is the input image. So initially the input image will appear in colored format. So now I will show you the input image. So this is the input image. So that's all about the edge detection using fuzzy logic. The next one we are going to do segmentation using active control. So here you can see initially we are using coins.image displaying that one. Then we are creating a mask of size 20:2. End is nothing but the last value. So row, comma, column. So from 25th row to end minus 25th row. From 25th column to end 25th column. End minus 25th column. Those values are set as 1, which is nothing but white color. So mask is created. Based upon the mask, we are going to do contour. So till how many iterations we have to do? Till 300 iterations we can do. This number is also based on test and trial. So if you apply just 100 alone means few areas may not be segmented properly. So for this image, 300 count is the best one. So that's why they have did up to 300. Now I will show you the execution of this part. Here you can see the input image. There are nearly 10 coins are there. And this particular coin alone appears more black when you compare to the remaining coins. So next stage is we have to create the initial contour location, which is nothing but the mask. Then here you can see the number of iteration is 100. So all the objects are not perfectly segmented. So we need to increase the iteration. So we in our code we increased up to 300 iteration. So when you run for 300 iteration, you can see the all the objects are perfectly segmented. So that's all about this session. So in this session, we have covered 4 codings. So if you have any doubt in the code, you can just message me in the comment section. So the codes what we have discussed are image segmentation using k-means clustering, face detection and tracking using KLT algorithm, edge detection using fuzzy logic. The last one, active contour segmentation. Thank you for watching.